Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are working at a financial institution that stores mortgage loan approval documents on cloud storage. Any change to these approval documents must be uploaded as a separate approval file, so you want to ensure that these documents cannot be deleted or overwritten for the next 5 years. What should you do? The options are: Option A, create a retention policy on the bucket for the duration of 5 years. Create a lock on the retention policy. Option B, create the bucket with uniform bucket level access, and grant a service account the role of object writer. Use the service account to upload new files. Option C, use a customer-managed key for the encryption of the bucket. Rotate the key after 5 years. Option D, create the bucket with fine-grained access control, and grant a service account the role of object writer. Use the service account to upload new files.
To arrive at the correct answer, we focus on the keywords: cloud storage, cannot be deleted or overwritten for the next 5 years.
The correct answer is Option A, create a retention policy on the bucket for the duration of 5 years. Create a lock on the retention policy.
Why is this correct? A cloud storage retention policy specifies a retention period during which objects in a bucket cannot be deleted or overwritten. Locking the policy permanently enforces this rule, preventing anyone, including administrators, from removing the policy or modifying the objects before 5 years elapse. Why are the others incorrect? B. Uniform bucket level access standardizes IAM permissions across the bucket but does not enforce a time-based lock to prevent authorized users or service accounts from deleting or overwriting objects. C. Customer managed encryption keys, CMEK, and key rotation manage data encryption at rest, but they do not prevent objects from being deleted or overwritten. D. Fine-grained access control configures individual object ACLs, but it does not restrict users with write access from deleting or overwriting files within the 5-year window.
Your team will start developing a new application using microservices architecture on Kubernetes Engine. As part of the development lifecycle, any code change that has been pushed to the remote develop branch on your GitHub repository should be built and tested automatically. When the build and test are successful, the relevant microservice will be deployed automatically in the development environment. You want to ensure that all code deployed in the development environment follows this process. What should you do? The options are: Option A, have each developer install a pre-commit hook on their workstation that tests the code and builds the container when committing on the development branch. After a successful commit, have the developer deploy the newly built container image on the development cluster. Option B, install a post-commit hook on the remote Git repository that tests the code and builds the container when code is pushed to the development branch. After a successful commit, have the developer deploy the newly built container image on the development cluster. And the remaining options are: Option C, create a cloud build trigger based on the development branch that tests the code, builds the container, and stores it in container registry. Create a deployment pipeline that watches for new images and deploys the new image on the development cluster. Ensure only the deployment tool has access to deploy new versions. Option D, create a cloud build trigger based on the development branch to build a new container image and store it in container registry. Rely on vulnerability scanning to ensure the code tests succeed. As the final step of the cloud build process, deploy the new container image on the development cluster. Ensure only cloud build has access to deploy new versions.
To arrive at the correct answer, we focus on the keywords: Kubernetes Engine, pushed to the remote develop branch, built and tested automatically, deployed automatically in the development environment.
Review the options on screen. The correct answer is option C. Create a cloud build trigger based on the development branch that tests the code, builds the container, and stores it in container registry. Create a deployment pipeline that watches for new images and deploys the new image on the development cluster. Ensure only the deployment tool has access to deploy new versions.
Why is this correct? C. Cloud build triggers automate testing, building, and storing images upon GitHub pushes. Using an automated deployment pipeline watching container registry and restricting deployment privileges exclusively to the pipeline ensures all deployed code strictly follows the automated CI/CD process. Why are the others incorrect? A. Pre-commit hooks run locally on developer workstations and can be bypassed. Having developers manually deploy images fails the requirement for automated deployment and strict process enforcement. B. Post-commit hooks requiring manual deployment by developers fail to automate the deployment phase and do not prevent unauthorized or manual deployments directly to the cluster. D. Container registry vulnerability scanning checks container images for known security vulnerabilities. It does not execute application code or unit tests to verify software functionality.
Your operations team has asked you to help diagnose a performance issue in a production application that runs on Compute Engine. The application is dropping requests that reach it when under heavy load. The process list for affected instances shows a single application process that is consuming all available CPU, and autoscaling has reached the upper limit of instances. There is no abnormal load on any other related systems, including the database. You want to allow production traffic to be served again as quickly as possible. Which action should you recommend? The options are: Option A, change the autoscaling metric to agent.googleapis.com/memory/%_used. Option B, restart the affected instances on a staggered schedule. Option C, SSH to each instance and restart the application process. Option D, increase the maximum number of instances in the autoscaling group.
To arrive at the correct answer, we focus on the keywords: Compute Engine, consuming all available CPU, autoscaling has reached the upper limit of instances, allow production traffic to be served again as quickly as possible.
The correct answer is option D, increase the maximum number of instances in the autoscaling group.
Why is this correct? D. Increasing the maximum instance limit in the autoscaling group allows the managed instance group to immediately scale out and spin up more instances, distributing the CPU-bound traffic load and quickly restoring service capacity. Why are the others incorrect? A. Changing the autoscaling metric to memory usage does not resolve the bottleneck, as the application process is CPU-bound, not memory-bound. B. Restarting instances on a staggered schedule temporarily reduces available capacity even further and fails to address the lack of total compute resources. C. Manually SSHing into each instance to restart the process is slow, unscalable, and does not solve the overall compute capacity limit under heavy load.
You are implementing the infrastructure for a web service on Google Cloud. The web service needs to receive and store the data from 500,000 requests per second. The data will be queried later in real time, based on exact matches of a known set of attributes. There will be periods where the web service will not receive any requests. The business wants to keep costs low. Which web service platform and database should you use for the application? The options are: Option A, Cloud Run and BigQuery. Option B, Cloud Run and Cloud Bigtable. Option C, a Compute Engine Autoscaling Managed Instance Group and BigQuery. Option D, a Compute Engine Autoscaling Managed Instance Group and Cloud Bigtable.
To arrive at the correct answer, we focus on the keywords: 500,000 requests per second, queried later in real time, exact matches of a known set of attributes, not receive any requests, keep costs low.
Correct answer is option B, Cloud Run and Cloud Bigtable.
Why is this correct? B. Cloud Run automatically scales to 0 when traffic stops, minimizing costs during idle periods. Cloud Bigtable handles extreme write throughput, 500,000 requests per second, and provides low latency, real-time lookups based on exact attribute matches. Why are the others incorrect? A. BigQuery is designed for OLAP analytical queries rather than high-throughput, low-latency real-time point lookups and writes. C. Compute engine managed instance groups cannot cost-effectively scale to zero like Cloud Run, and BigQuery is not suitable for low-latency real-time lookups. D. Compute engine managed instance groups incur operational overhead and baseline costs during idle periods compared to serverless Cloud Run.
You are developing an application using different microservices that should remain internal to the cluster. You want to be able to configure each microservice with a specific number of replicas. You also want to be able to address a specific microservice from any other microservice in a uniform way, regardless of the number of replicas the microservice scales to. You need to implement this solution on Google Kubernetes Engine. What should you do? The options are: Option A, deploy each microservice as a deployment. Expose the deployment in the cluster using a service, and use the service DNS name to address it from other microservices within the cluster. Option B, deploy each microservice as a deployment. Expose the deployment in the cluster using an ingress, and use the ingress IP address to address the deployment from other microservices within the cluster. Option C, deploy each microservice as a pod. Expose the pod in the cluster using a service, and use the service DNS name to address the microservice from other microservices within the cluster. Option D, deploy each microservice as a pod. Expose the pod in the cluster using an ingress, and use the ingress IP address name to address the pod from other microservices within the cluster.
To arrive at the correct answer, we focus on the keywords: internal to the cluster, specific number of replicas, address a specific microservice, Google Kubernetes Engine.
The correct answer is option A, deploy each microservice as a deployment. Expose the deployment in the cluster using a service, and use the service DNS name to address it from other microservices within the cluster.
Why is this correct? A. A deployment manages scaling to a specific number of replicas. Exposing the deployment internally using a Kubernetes service provides a stable, uniform DNS name for inter-service communication regardless of scaling. Why are the others incorrect? B. Ingress is used to expose HTTP/HTTPS routes from outside the cluster to internal services, making it unsuitable for internal microservice-to-microservice traffic. C. Standalone pods do not support replica management or automated scaling, which requires a workload controller like a deployment. D. Standalone pods cannot manage multiple replicas, and ingress is meant for external entry points rather than internal service-to-service DNS discovery.
Your company has a networking team and a development team. The development team runs applications on compute engine instances that contain sensitive data. The development team requires administrative permissions for compute engine. Your company requires all network resources to be managed by the networking team. The development team does not want the networking team to have access to the sensitive data on the instances. What should you do? The options are: Option A, 1. Create a project with a standalone VPC and assign the network admin role to the networking team. 2. Create a second project with a standalone VPC and assign the compute admin role to the development team. 3. Use Cloud VPN to join the two VPCs. Option B, 1. Create a project with a standalone virtual private cloud, VPC, assign the network admin role to the networking team, and assign the compute admin role to the development team. Option C, 1. Create a project with a shared VPC and assign the network admin role to the networking team. 2. Create a second project without a VPC, configure it as a shared VPC service project, and assign the compute admin role to the development team. Option D, 1. Create a project with a standalone VPC and assign the network admin role to the networking team. 2. Create a second project with a standalone VPC and assign the compute admin role to the development team. 3. Use VPC peering to join the two VPCs.
To arrive at the correct answer, we focus on the keywords: compute engine, administrative permissions for compute engine, all network resources to be managed by the networking team, development team does not want the networking team to have access.
The correct answer is option C. 1. Create a project with a shared VPC and assign the network admin role to the networking team. 2. Create a second project without a VPC, configure it as a shared VPC service project, and assign the compute admin role to the development team.
Why is this correct? C. Using a shared VPC separates network administration in the host project from compute administration in the service project. The networking team manages all network resources centrally, while the development team retains administrative control over their compute engine instances and sensitive data without network admins accessing instance contents. Why are the others incorrect? A. Connecting two standalone VPCs using Cloud VPN introduces unnecessary routing complexity, cost, and maintenance overhead compared to using shared VPC for central network management. B. Assigning both network admin and compute admin roles in the same project allows the networking team potential access to compute resources and violates the segregation of network management duties. D. Using VPC peering requires the development team to manage their own standalone VPC, which violates the requirement for all network resources to be managed centrally by the networking team.
Your company wants you to build a highly reliable web application with a few public APIs as the backend. You don't expect a lot of user traffic, but traffic could spike occasionally. You want to leverage cloud load balancing, and the solution must be cost-effective for users. What should you do? The options are: Option A, store static content such as HTML and images in Cloud CDN. Host the APIs on App Engine and store the user data in Cloud SQL. Option B, store static content such as HTML and images in a cloud storage bucket. Host the APIs on a zonal Google Kubernetes Engine cluster with worker nodes in multiple zones, and save the user data in Cloud Spanner. Option C, store static content such as HTML and images in Cloud CDN. Use Cloud Run to host the APIs and save the user data in Cloud SQL. Option D, store static content such as HTML and images in a cloud storage bucket. Use Cloud Functions to host the APIs and save the user data in Firestore.
To arrive at the correct answer, we focus on the keywords: don't expect a lot of user traffic, traffic could spike occasionally, cloud load balancing, cost-effective.
The correct answer is option D, store static content such as HTML and images in a cloud storage bucket. Use Cloud Functions to host the APIs and save the user data in Firestore.
Why is this correct? D. Cloud Functions in Firestore scale down to 0 when idle, making them highly cost-effective for low-traffic applications while easily handling sudden traffic spikes. Cloud storage provides inexpensive static hosting, and Cloud Functions integrates with cloud load balancing via serverless NEGs. Why are the others incorrect? A. Cloud SQL incurs ongoing baseline charges even when idle, and using Cloud CDN for low-traffic static content adds unnecessary costs compared to serving directly from cloud storage. B. Google Kubernetes Engine, GKE, and Cloud Spanner are designed for high-throughput enterprise workloads and carry high fixed costs, making them non-cost-effective for low-traffic scenarios. C. While Cloud Run is cost-effective, Cloud SQL requires paying for continuously running database instances, which is significantly more expensive than a scale-to-zero serverless database like Firestore.
Your company sends all Google Cloud logs to Cloud Logging. Your security team wants to monitor the logs. You want to ensure that the security team can react quickly if an anomaly such as an unwanted firewall change or server breach is detected. You want to follow Google recommended practices. What should you do? The options are: Option A, schedule a cron job with Cloud Scheduler. The scheduled job queries the logs every minute for the relevant events. Option B, export logs to BigQuery, and trigger a query in BigQuery to process the log data for the relevant events. Option C. Export logs to a pub/subtopic and trigger cloud function with the relevant log events. Option D. Export logs to a cloud storage bucket and trigger cloud run with the relevant log events.
To arrive at the correct answer, we focus on the keywords, cloud logging, react quickly if an anomaly, Google recommended practices.
The correct answer is option C, export logs to a pub/subtopic, and trigger cloud function with the relevant log events.
Why is this correct? C. Exporting logs to a pub/subtopic enables real-time, event-driven streaming. Triggering a cloud function directly from the pub/subtopic allows the security team to react immediately to critical anomalies, which aligns with Google recommended event-driven monitoring practices. Why are the others incorrect? A. Polling logs via Cloud Scheduler is inefficient, introduces latency, and is not a real-time event-driven approach for security response. B. Exporting logs to BigQuery is designed for analytical queries and historical analysis, not for immediate real-time event processing and alerts. D. Cloud storage log exports are batched and intended for long-term archiving, making them unsuitable for real-time alerting and quick anomaly response.
You have deployed several instances on Compute Engine. As a security requirement, instances cannot have a public IP address. There is no VPN connection between Google Cloud and your office, and you need to connect via SSH into a specific machine without violating the security requirements. What should you do? The options are: Option A, configure Cloud NAT on the subnet where the instance is hosted. Create an SSH connection to the Cloud NAT IP address to reach the instance. Option B, add all instances to an unmanaged instance group. Configure TCP proxy load balancing with the instance group as a backend. Connect to the instance using the TCP proxy IP. Option C, configure Identity-Aware Proxy, IAP, for the instance and ensure that you have the role of IAP secured tunnel user. Use the Cloud Command Line tool to SSH into the instance. Option D, create a Bastion host in the network to SSH into the Bastion host from your office location. From the Bastion host, SSH into the desired instance.
To arrive at the correct answer, we focus on the keywords, Compute Engine, cannot have a public IP address, no VPN connection, connect via SSH.
The correct answer is option C, configure Identity-Aware Proxy, IAP, for the instance and ensure that you have the role of IAP secured tunnel user. Use the Cloud Command Line tool to SSH into the instance.
Why is this correct? C. Identity-Aware Proxy, IAP, TCP forwarding allows secure SSH connections to Compute Engine instances without public IP addresses or VPN connectivity using the Cloud Compute SSH command and the IAP secured tunnel user IAM role. Why are the others incorrect? A. Cloud NAT provides outbound internet connectivity for instances without public IP addresses, but it does not support inbound connections like SSH. B. TCP proxy load balancing is designed for distributing external TCP application traffic across backends, not for direct administrative SSH management of specific individual instances. D. Creating a Bastion host accessible from the office requires assigning it a public IP address, which directly violates the security requirement prohibiting public IPs on instances.
Your company is using Google Cloud. You have two folders under the organization, Finance and Shopping. The members of the development team are in a Google group. The development team group has been assigned the project owner role on the organization. You want to prevent the development team from creating resources in projects in the Finance folder. What should you do? The options are: Option A, assign the development team group the project viewer role on the Finance folder, and assign the development team group the project owner role on the Shopping folder. Option B, assign the development team group only the project viewer role on the Finance folder. Option C, assign the development team group the project owner role on the Shopping folder, and remove the development team group project owner role from the organization. Option D, assign the development team group only the project owner role on the shopping folder.
To arrive at the correct answer, we focus on the keywords, finance and shopping, project owner role on the organization, prevent the development team from creating resources and projects in the finance folder.
The correct answer is option C, assign the development team group the project owner role on the shopping folder, and remove the development team group project owner role from the organization.
Why is this correct? C. IAM permissions in GCP are inherited down the resource hierarchy and cannot be revoked at lower levels. Removing the project owner role from the organization level prevents inheritance into the finance folder, and granting it specifically on the shopping folder grants access only where needed. Why are the others incorrect? A. IAM permissions are additive and hierarchical. Assigning the project viewer role on the finance folder does not override or restrict the project owner role inherited from the organization level. B. Granting a less permissive role at a child level does not remove or restrict the broader permissions inherited from the organization level. D. Failing to explicitly remove the project owner role from the organization level leaves the inherited permissions active across all folders, including finance.
You are developing your microservices application on Google Kubernetes Engine. During testing, you want to validate the behavior of your application in case a specific microservice should suddenly crash. What should you do? The options are: Option A, add a taint to one of the nodes of the Kubernetes cluster. For the specific microservice, configure a pod anti-affinity label that has the name of the tainted node as a value. Option B, use Istio's fault injection on the particular microservice whose faulty behavior you want to simulate. Option C, destroy one of the nodes of the Kubernetes cluster to observe the behavior. Option D, configure Istio's traffic management features to steer the traffic away from a crashing microservice.
To arrive at the correct answer, we focus on the keywords, Google Kubernetes Engine, validate the behavior, specific microservice should suddenly crash.
The correct answer is option B, use Istio's fault injection on the particular microservice whose faulty behavior you want to simulate.
Why is this correct? B. Istio's fault injection mechanism allows testing application resiliency by introducing artificial failure conditions, such as delays or HTTP aborts, directly into specific microservices without disrupting physical cluster infrastructure. Why are the others incorrect? A. Taints and pod anti-affinity influence pod scheduling on nodes, but they do not simulate microservice failure or application-level crash scenarios. C. Destroying an entire node tests infrastructure-level resiliency and pod rescheduling, not the isolated application behavior when a specific microservice crashes. D. Traffic management features steer traffic away from unhealthy services for load balancing, rather than injecting faults to test application behavior during a service failure.
Your company is developing a new application that will allow globally distributed users to upload pictures and share them with other selected users. The application will support millions of concurrent users. You want to allow developers to focus on just building code without having to create and maintain the underlying infrastructure. Which service should you use to deploy the application? The options are: Option A, App Engine. Option B, Cloud Endpoints. Option C, Compute Engine. Option D, Google Kubernetes Engine.
To arrive at the correct answer, we focus on the keywords, millions of concurrent users, focus on just building code, without having to create and maintain the underlying infrastructure.
The correct answer is option A, App Engine.
Why is this correct? A. App Engine is a fully managed serverless platform as a service, PaaS, that automatically scales to handle high concurrency while allowing developers to focus solely on code without managing underlying infrastructure. Why are the others incorrect? B. Cloud Endpoints is an API management tool used to secure and monitor APIs, not an application hosting platform for deploying application code. C. Compute Engine is an infrastructure as a service (IaaS) offering that requires developers to provision, configure, and maintain virtual machines and underlying infrastructure. D. Google Kubernetes Engine (GKE) requires developers and operators to manage Kubernetes clusters, pod configurations, and node infrastructure, adding operational complexity.
Your company provides a recommendation engine for retail customers. You are providing retail customers with an API where they can submit a user ID and the API returns a list of recommendations for that user. You are responsible for the API lifecycle and want to ensure stability for your customers in case the API makes backward incompatible changes. You want to follow Google recommended practices. What should you do? The options are: Option A, create a distribution list of all customers to inform them of an upcoming backward incompatible change at least 1 month before replacing the old API with the new API. Option B, create an automated process to generate API documentation and update the public API documentation as part of the CI/CD process when deploying an update to the API. Option C, use a versioning strategy for the APIs that increases the version number on every backward incompatible change. Option D, use a versioning strategy for the APIs that adds the suffix deprecated to the current API version number on every backward incompatible change. Use the current version number for the new API.
To arrive at the correct answer, we focus on the keywords: API lifecycle, backward incompatible changes, Google recommended practices.
The correct answer is option C. Use a versioning strategy for the APIs that increases the version number on every backward incompatible change.
Why is this correct? C. Incrementing the major version number for backward incompatible changes allows existing clients to continue using the legacy API version safely, adhering to Google's API design guidelines for managing breaking changes. Why are the others incorrect? If notifying customers without maintaining the old version forces breaking changes onto existing clients, disrupting service and violating API stability guidelines. B. Generating automated documentation updates alone does not prevent existing client applications from breaking when non-backward compatible API changes are deployed. D. Appending a deprecated suffix changes the endpoint URI, breaking existing integrations immediately rather than allowing clients to transition gracefully.
Your company has developed a monolithic, 3-tier application to allow external users to upload and share files. The solution cannot be easily enhanced and lacks reliability. The development team would like to re-architect the application to adopt microservices and a fully managed service approach, but they need to convince their leadership that the effort is worthwhile. Which advantages should they highlight to leadership? The options are: Option A, the new approach will be significantly less costly, make it easier to manage the underlying infrastructure, and automatically manage the CI/CD pipelines. Option B, the monolithic solution can be converted to a container with Docker. The generated container can then be deployed into a Kubernetes cluster. Option C, the new approach will make it easier to decouple infrastructure from application, develop and release new features, manage the underlying infrastructure, manage CI/CD pipelines and perform A/B testing, and scale the solution if necessary. Option D, the process can be automated with Migrate for Compute Engine.
To arrive at the correct answer, we focus on the keywords: monolithic, 3-tier application, microservices and a fully managed service approach. Advantages should they highlight to leadership?
The correct answer is option C. The new approach will make it easier to decouple infrastructure from application, develop and release new features, manage the underlying infrastructure, manage CI/CD pipelines and perform A/B testing, and scale the solution if necessary.
Why is this correct? C. Adopting microservices and fully managed services decouples application logic from infrastructure, enabling faster feature releases, easier scaling, simplified infrastructure management, and streamlined CI/CD with support for advanced deployment strategies like A/B testing. Why are the others incorrect? A. Microservices and managed services do not guarantee significantly lower costs or automatically create and manage CI/CD pipelines without explicit setup. B. Containerizing the monolithic application into Docker and Kubernetes is a lift and shift approach, not re-architecting into microservices and fully managed services. D. Migrate for Compute Engine automates virtual machine migration to Google Cloud, which performs lift and shift rather than refactoring an application into microservices.
Your team is developing a web application that will be deployed on Google Kubernetes Engine, GKE. Your CTO expects a successful launch and you need to ensure your application can handle the expected load of tens of thousands of users. You want to test the current deployment to ensure the latency of your application stays below a certain threshold. What should you do? The options are: Option A, use a load testing tool to simulate the expected number of concurrent users and total requests to your application, and inspect the results. Option B, enable autoscaling on the GKE cluster and enable horizontal pod autoscaling on your application deployments. Send curl requests to your application, and validate if the autoscaling works. Option C, replicate the application over multiple GKE clusters in every Google Cloud region. Configure a global HTTPS load balancer to expose the different clusters over a single global IP address. Option D, use Cloud Debugger in the development environment to understand the latency between the different microservices.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, GKE, expected load of tens of thousands of users, test the current deployment, latency of your application stays below a certain threshold.
The correct answer is option A. Use a load testing tool to simulate the expected number of concurrent users and total requests to your application, and inspect the results.
Why is this correct? A. Load testing tools simulate heavy traffic by generating realistic concurrent requests, enabling you to measure application response times and verify latency thresholds under peak expected load. Why are the others incorrect? B. Manual curl requests cannot generate sufficient traffic to simulate tens of thousands of concurrent users or evaluate application latency under load. C. Replicating deployments across regions provides high availability and traffic distribution, but it does not test how the application performs under high load. D. Cloud Debugger is used to inspect application state in real time without stopping execution. It does not perform load simulation or measure overall system latency.